Activity 5A deals with graph transformations. So the main idea here is we're trying to teach students how to shift graphs, how to stretch graphs, and how to flip them. The thought is that groups will graph a set of equations on Desmos and tell us what they see. So the way I'm going to do this is maybe table by table. Group A will graph group 1 here. Group B will graph set 2 here, maybe a different table. Somebody will graph set 3. So best if you have students that have somebody at a table with their computer plugged in to the monitor. So if I'm in a classroom that has 6 tables, maybe table 1, I make sure that on their screen we can see the group 1 stuff. Group 2, group 3. Tables can look at other tables to see what's on their screen. There's going to be a shape. So group 1, you're going to see a parabola shape. Group 2, you're going to see the square root shape. Group 3, you're going to see the logarithm shape. And that shape is going to change graph to graph. And the goal is just to get them to graph a bunch of stuff, see what they see, thing that we'll want to tease out eventually, and most groups are pretty good with this. How do we tell left-right shifts from up-down shifts? What is it about the equation that will tip you off which way it's moving? So what they should see in number 1 is the shape stays the same. The graph just moves one way or the other. And tease out the fact that sometimes the change is up-down, sometimes the change is left-right, and it has to do with the location of the thing causing the change in relationship to x. Maybe they're ready for some talk about function notation, that there is putting the modifier in the parentheses with the x before you plug it into the function. So it's an input thing, it's a left-right thing. Once you've applied the function, the square root, the log, then the changes will happen in the vertical direction. So step 1, just to get them to see that the D is shifting it up and down, the C is shifting it left and right. They probably at this point, they can already get used to the fact that the Y changes will make sense, plus is up, but the X changes are the opposite of what you expect. Plus goes left and minus goes right. Not looking for students to know a lot about the sine function. Just there is the sine function. It's a graph of whatever. You may want to tell them it's a wave, but don't go into too much detail. Maybe they've put it on their computer screen on Desmos. It's a wave. They should understand that this plus 4 is going to move the graph up, and that this minus pi over 4 is going to move the graph to the right. Simple as that. Translations, we're just shifting the graph, keeping the shape the same. After they're done with the first set, they can move on to the second set. Again, maybe you mix things up or not, but get different screens showing different things. Again, here you should see that for instance, the origin will not change in the square root graph. The others you're going to recognize, it's the same shape, it's just reflected or mirrored. Students will want to talk about, it's reflected across the x-axis, it's reflected across the y-axis. That's kind of the notation they're used to, the terminology they're used to. I tend to state it always with X transformations saying something about what's happening horizontally, and Y transformations saying something about what's happening vertically. So for instance, y equals square root of x, y equals negative square root of x. Students will say, oh, that gets reflected across the x-axis, but it's outside the function, and so we're thinking of it as a vertical transformation. And so I try to use some vertical language, like it gets flipped top to bottom. Again, they get this pretty quickly. These are flips. Worth a little bit of time, since we're coming up on a parabola lesson, to talk about this bullet point here. Why do these two graphs look the same? Shouldn't the graph be flipped? Well, yes, it is flipped, but it's flipped in the x direction, left to right. And because it's symmetric left and right, you're just flipping it onto itself. The left arm becomes the right arm becomes the left arm, but it's the same graph because of the symmetry. Again, same thing. And this one actually isn't all that great to look at Desmos, because both of these things accomplish the same thing, that flipping the wave graph top to bottom and flipping the wave graph left to right make it look the same. Probably better to point out things that are happening up here, because these graphs all have unique features that show up differently in all four cases. And then we stretch the graphs. Again, students are not expected to know that this is going to be a half circle. They're not expected to know what arcsine, arctangent are. On Desmos, it uses the -1 inverse notation, inverse sine and inverse tangent, so may need to point that out to students. Although I think it may work if you just type in arcsine and arctangent. But again, same thing. Here, some of these graphs, it's a little harder for students to see. And so I think focusing them on the arcsine graph will have endpoints. So pay attention to where the endpoints are. Same thing, the half circle builds a little tunnel. You can see where those endpoints are, and you can see where those endpoints are moving. Worth spending a couple of minutes back again to the sine graph now. One transformation makes the waves taller, the other makes the waves thinner. And so some students may be familiar with the physics terminology about frequency and wavelength and period. But again, just a matter of getting students to notice these graphs are getting stretched, where the vertical stretch makes sense, makes it taller. The horizontal stretch goes the opposite, is actually a squish and makes it thinner. To get them to the summary, and they may get to the summary pretty quickly, maybe well before the end of the hour. How do you move graphs? How do you stretch graphs? How do you flip graphs? How do you tell whether something is going to be a horizontal or a vertical effect? And specifically, which direction will it go? The y's do what you expect them to do. Plus moves up. Multiplication makes it taller. The x's do the opposite of what you expect. Addition moves it to the left. And multiplication makes it thinner, not wider. Good to get them explaining. And again here, the students are kind of want to do, I want to calculate answers. I'm not telling you what f is, so you don't have the ability to calculate anything about this function. This is purely a visual thing. If you see a picture, how does the picture change? It moves down, it flips, it gets taller, it gets thinner. It's those sorts of descriptions that we're looking at. There's a follow-up report that maybe you pull up during class. It shows a picture of some mountains and then has the students transform the mountains. And they, so again, They have some inclination to try to do some calculation. Oh, I see a 2, I must be multiplying something by 2. Try to get them back to the purely visual thing. You're taking this picture and you're modifying the picture by moving the graph, stretching the graph, flipping the graph. That's activity 5A.